Okay, a couple of equipment conditions that will cause a belt to mistrack is anytime you have bent, loose, or misaligned rollers or structure. All rolling components steer the belt. In order for a rolling component to steer the belt correctly, it must also be, fill that in, must be aligned. So if I've got rollers that are out of alignment like I see in photo 1, or if I've got structure misalignment like I see in photo 2, then I'm going to cause that belt to mistrack. Okay, so we got to make sure that all pulleys are aligned. And when I say pulleys aligned, we're really talking specifically about what we refer to as terminal pulleys. All the terminal pulleys must be aligned. So the terminal pulleys on this particular conveyor is going to mean the tail pulley and the head pulley, but it is also going to include a snub pulley if there is one, bend pulleys if you have them, and then the take-up pulleys. So these 6 pulleys must be aligned. If those 6 terminal pulleys aren't aligned, that belt's not going to track properly. One of the most overlooked reasons why a belt mistracks is because of improper splicing and improper belt storage. So the photo on the left, photo 1, is an example of what we call a pretty square splice. A lot of facilities, if they're squaring, when they go to cut a belt, if you square off this edge, let's say you set a framing square off that edge, assume that's a 90-degree angle. If you were to set a framing square off this edge or this edge, those edges may not be straight. It's not uncommon for those edges of a belt to be cut, and therefore they might have a little bit of a wave to them. So if you're using the edge of the belt to get a square cut to the belt, you'll have what's called a crooked splice. And you can identify a crooked splice. If you go to, say, a tail pulley, and you watch that belt, watch that belt, watch that belt, watch that belt, and then all of a sudden that splice comes through, and you see that's all of a sudden that belt jump very quickly to one side and jump back. That's a crooked splice. That happens because they've squared off this edge of the belt. What you need to do is create what's called an average center line by measuring half the distance from each side of the belt, striking marks, and then connecting those marks that you've created with a chalk line. That's giving you your average center line. Square off of that. Okay, another concern that you should be thinking about is stand at the tail pulley and watch that belt, and if it slowly walks, slowly walks, slowly walks, and then slowly walks back, that's a little bit different. That's called camber. Belt slowly walks to one side and then eventually comes back. What you're seeing here is a curvature in that belt. So if you were to roll that belt out straight, you would want this line from edge to edge to not deviate more than about 1 inch per 100 feet. If that belt were to deviate more than 1 inch per 100 feet in length, that belt has camber. What camber is, it's a stretch on one side of the belt, but not the other, that can cause the belt to mistrack. And that camber comes from storing the belt improperly. So it's really important that you store belts on a rack like you see in the photo below. What we don't want to do is store a belt on the ground like this. we store a belt on the ground like you see in this photo, here's the ground, here's my belt, all the weight is on one side of the belt, and that's damaging that carcass on that side. That creates a elongation to one side of the belt, causing the belt to mistrack. Another reason why a belt can mistrack is anytime the belt's cupped. So if we don't have our rolling component touching the belt, it's not going to steer the belt correctly. We got to make sure that that rolling component is in contact with the belt. Your belts can cup because they're over tensioned. So if you have too much stretch on that belt, that can cause it to cup. Heat, if you're running hot material, if you're running, let's say you're pulling coal off the pile, that smoldering coal, that can cause that belt to cup. If you're running hot material, that can cause the belt to cup. Certain chemicals could cause the belt to cup. There can sometimes be a chemical reaction between the chemical that you might be using and the compound of the rubber. That can cause the belts to cup. And then also if you exceed the troughability or trough angle of the belt. Another reason a belt might not make full contact with a rolling component is what we call junction joint failure. Junction joint failure is kind of, some people call it an M belt. And the reason why a lot of guys call it the M belt is because it looks like an M as it approaches the rolling component or a return roll. And you can kind of see that here. So if a belt has junction joint failure, it makes good contact here, here, and here, but you can see the daylight right here. Now, eventually junction joint failure can actually cause damage in the idler junction area of the belt, but you will first see it here. Junction joint failure comes from the belt being forced into its trough too soon. See, when you take the belt off the tail pulley's flat, and then you form that belt into its trough. When you do that, you put a lot of stress on the belt. And that stress is okay if there's enough real estate for it to happen. But a lot of design forces that belt into its trough without enough real estate. So when that belt is taken from a flat tail pulley to this fully troughed idler in too short of a distance, that'll cause that junction joint failure.